will see a green line, and please focus on here. Now you have 1 day and 16 hours to do the lab. So which means you will be able to do the lab on Saturday. So please enjoy that.
Thank you very much for that.
George,
Yeah, I already give it to you.
will you give it to me?
Yeah.
You mean
Oh, okay, I'm sorry.
Okay, thank you.
one?
Oh, 1 second.
Okay, let's get started. We have 4 chapters to go, but no worry. 4 chapters is quite easy because chapter 12, 13, 14, they are all about the monitoring and some of the security. And then one of the chapter, which is the last chapter for today, it will give you a concept how to install the contract, and you also have a lab to practice on it. So that's important because I know that you are going to use the control. But before you use the control, you might want to install it in case if there's anything wrong, that in the future you need to reinstall. All right, so in chapter 12, control monitoring and analytics. In this chapter, we are going to explain the function of control analytics and describe how to work with monitor workspace. Discuss how to run flow queries and examine system logs. Use control analytics API. Right, so first, analytics overview. Analytics, what is analytics? Which means we would like to collect the information, including the layer 1, layer 2, layer 3, or even the higher layer information. How many packets, how many bytes, and how many traffic, how many workload in your network. When we talk about this, normally in the old day, we used SNMP. But SNMP is a quite old protocol and is not a very good protocol because SNMP is using a kind of style to we call it pooled information. You need to send a request to the device and pool the information from the device. And normally it will generate a lot of the traffic. So in nowadays, when everybody talking about analytics, everybody actually not talking about the SNMP. Instead, we are talking about telemetry. Telemetry, which means unless you have something wrong, okay, I just give you a threshold. Unless you exceed the threshold, you send the traffic to me. So in this case, I want to minimize the bandwidth usage as minimum as possible. So that is how it works. We use the way we call it pool. Okay, pool. So I give you a threshold, and you monitor by yourself. If there is something wrong exceeding the threshold, give it to me. All right. In order to get the information, some of the terms that we need to know in control. For example, what is flow? And what is UVE? What is log? What is infrastructure statistic? Before I starting with this flow, I need to ask a very simple question for everybody. What's the difference between flow and session?
Flow and session.
Flow one direction session.
Wow, exactly that kind of meaning. Yes, flow is one direction, session is bi-direction. So remember that we will talk about the stateful firewall yesterday, right? Stateful firewall need to record the first packet and anticipate the second entry. So anticipate the second entry, that will be what will be the traffic coming back looks like. So if I can know both of the entry, I will know both of the direction. So that will be the session. But normally when we're doing the analysis, we are talking about the flow. We're caring about from A sending to B, how many traffic. And if we would like to see from B sending to A, that will be another job to do. Okay, you will have to create another flow. And then user visible entity. User visible entity including, oh, if I have a flow the flow is A to B. So can you tell me more details about the information? For example, which VM sending to which VM? From which network card to which network card? And pass through which virtual router to which virtual router? So if you can give me that, I not only see the traffic, I also can see what's the entity they pass through. So I see everything in the underlay. We call it VUE. So that kind of information can be collected by using control as well. And of course, we're also supporting the standard log. The standard log that will be generated by each of the nodes in your control. So when we talk about the nodes, there are so many nodes. Three of most important nodes, what are they? Config node, control node, and one more, analytics node. Okay, try to remember these three terms. And all these nodes will generate their log and sending to the analytics node. Analytics node will be the concentrator to collect all the other nodes information. And also we have the infrastructure statistic. Okay, what is infrastructure? Infrastructure, we are talking about the underlay. You have the spine, you have the leaf, you have a leaf connecting to an HP server with the GE001. Now, I know the server over there is an HP server connecting to the leaf device within the GE001. But inside that pipe, inside of the gigabit Ethernet, there are probably hundreds or even thousands of the virtual machine traffic passing through. Okay? So if you say A sending the traffic to B, you are talking about VM to VM. That is normally overlay. But what if I say, hey, I know A to B is passing through the traffic from which virtual machine, from which network card, from which V router? Can you tell me which interface, which physical port the traffic is actually passing through? G001 on the QFX 5100. Okay, that is the leaf device. So if you can tell me that, that is your infrastructure. And most likely you will have to know both. So in that case, we will give you both of the information. But instead of giving you the raw data, because if I give you the raw data, it doesn't mean anything, right? Because you can understand what is the data meaning what. So I will give you a full picture. The full picture on the web, telling you that there is an overlay passing through which physical interface connecting to which device. So that kind of the page, that kind of the graphic, we call it overlay underlay mapping. That's a very important term because every other vendor also supporting that. But who can give you more detailed information? Probably Control, because Control has been proven that is the number one product in the market. Maybe we can adjust the light.
Can you turn off this one? Yeah, no, leave this, can I have that off?
Turn off?
Yeah, keep that one off, because then I can see the screen easier, that just gives me a headache. I don't know about, do you get a headache? with
That's
that?
all right. All
No, do you get a headache with that light on?
right. I'm all right with this.
Yeah, because now you look at it.
It's very nice. Yeah.
As long as you won't sleep. You won't fall asleep.
No, no, no,
Okay, no problem.
You should have done on Monday actually. That's right.
yeah, because then you can.
Yeah, this is nice.
Oh, okay. Oh, sorry, I didn't notice that. I just like
It's
to say.
probably just that front one that's too close to it.
Okay, but I'm not able to adjust that.
That's,
No, that's all right.
Okay, in the control, we have the analytics components. So where is the analytics component? Which means who is going to collect the information? It's including the control node and the V router and the config nodes. So remember, we talked about in the control, we have three different nodes. One is config node. Another one is control node. And there is another node, we call it analytics node. And if you are talking about HP server, okay, HP server is in here, running with the hypervisor, and there is a V router, so we call it V router agent. Every node will sending their information to analytics node. And the analytics node will save that in the storage, in the database. So for you, you will be able to use the GUI to parse the information from the analytics. Analytics will give that information to you by using the GUI. And also, I know Sean is very interested about the API, right? Because every time I can imagine that every time you do the lab, you say, oh, API is great, it's quite nice. You can do something very fast. Yes. What if I say, hey, Sean, now you are the administrator of the contract. Now you have thousands or even hundred or even thousands of the virtual machine and thousands of the tunnel over there. Sean, I would like to know, I have currently received a call from my customer. The customer is ABC company, and they have purchased our product, which is VMware, and sorry, VSRX. And the customer asked me to provide a report to them, okay? And they want to know how many traffic passing through their virtual machine and in the Ohio and the Singapore data center. So Sean, can you do that for me?
Yeah, I wouldn't be doing it.
Okay, Sean will probably say, yes, you probably can do it, but you probably don't want to use the GUI. Because you have to find where is the virtual machine over there, where is the virtual machine in Singapore, right? Where is the tunnel, and you can go deep to every detail. And then you can figure out, and then you collect that information and generate the report, and probably 10 days later. So you can use the API. So again, we are providing an API. So you can use the API, you can use the script, and to tell the analytics, say, okay, just give you the criteria. I have a tenant called ABC. Okay, the ABC tenant has the virtual machine, 10 of the virtual machine in Ohio, another 10 virtual machine in Singapore, and I would like to know how many traffic passing through over this virtual machine, and what is the physical interface generating the traffic. So generate that information, give me a report, and the report should look like this, and there is a logo, Telstra, in the report. So that can be done by using.
Does that report give you graphs?
Well, it says that's
Yes.
the THT NoSQL database is used for scale and persistence. So basically, we use the API to grab all the data and then just export it to those
Yes.
files.
Right.
Well, the files would have that information in it.
Template. You grab the information by using the API and send it to the template.
So once I've got that information, then can I put it into some program to give them a graph? Because customers often just want.
Right. That's why I'm saying.
Yeah.
Yes.
It just said it contains graph.
No, but that says it's got, it doesn't just be a file with that information. It's going to have a graph.
This information will need to tell you that you can parse that information through the API. So I am telling you that the API will parse that information, parse that data,
To a
and
file,
send into a template.
a template, yeah.
A predefined template. The template will, for example, the template will search all the information you give it to them, and have a rank. For example, on the highest threshold will be A to B, and the lowest threshold, the traffic will be C to D, and give you a rank. You can use different templates, and then you say, oh, I will use this template because this template is what the customer needs. And I would like to put the logo, replace the Juniper logo by Telstra logo.
Sure.
So you can generate a very pretty report.
So we're gonna see that soon.
Sorry, that will be in another product.
Another course.
Another code.
We call it app formats.
Ah, okay,
Right.
that's what that's for. Yeah,
Yes.
alright.
In Contrail, we generate the data. In app formats,
You get to
you
view
download
it.
it.
You can view it.
Yes.
Yeah, okay. Because it's essentially it's just a file that you can't do anything with until you've got app formats.
Yes, app formats.
Yeah. know what I mean? Wallets, it's just, oh, well, it was here, here's this thing here. Oh, what do I do with it? Pay for this one.
Yeah.
So once again, the benefit is that you need a license. Yeah. One of the benefits is that it costs more money. Oh, right. Yeah.
Right, and in order to doing that, you have to make sure every components in your control are time synchronized with the NTP server. So NTP is very important. If you don't have the NTP synchronized, the log will not be correct. And here is how the database looks like. For example, we just talked about we have a node in the control called analytics. Here is the analytics. So analytics including from here to here. So where is the administrator? Administrator, oh, Sean, you are in here, right? And Sean said, okay, I would like to generate the information. So first of all, I need to parse the information from the database. So how? You are going to use the Python or YAML or HIT or CUIL, right? And that API will go to analytics client, all right? And the analytics client will talk to your node, that is analytics node. By using this protocol, REST. Again, REST is the northbound API protocol. And that request was sending to the REST API server in the control. And that will be used to query the database. And here is the database. Now, you might be able to receive the question in your exam. What kind of the database we are talking about in analytics?
Cassandra.
Cassandra. Yes, Cassandra.
What did you say was confidence server? Do you know what it is?
No, I just saw that.
Write a thesis on it.
No, I don't know anything about Cassandra. Come on. It's like Cassata, you know? It's nice. How do I know?
But actually, I love that redaction. That's good, that's good. You know what? Cassandra. Good. Yes.
You said that as you knew like 10 years ago.
All the
No.
development.
Come on.
And from the analytics node by itself, it won't generate the data unless the analytics know how to collect the information from the other nodes. For example, all other nodes, including the compute node. The information will be sending to analytics by using this protocol. All right, these protocols are the southbound protocol. So we have SendDash, we have SFlow, we have IPFix, we have SNMP, we have SLog, and etc. So why so many protocols over there? Do I need to use all of them? No. All this protocol is only to give you an option. Okay, depending on what kind of the server you are using here. For example, you purchasing an HP server. HP server say, oh, I know about the SendDash. You buy a Dell server over there. Dell server say, oh, I don't know what is the SendDash, but I know what is the SFlow. So that give you the option. And just like we said, F-Formats. F-Formats is another product. This product will help you to collect all the information. You see that there are so many pretty reports over there.
So
You
this
can-
is the template, yeah.
No, the
Oh,
template.
no, this is not the template. This is the dashboard.
Okay.
Yeah. There are some template that will help you to say, oh, I would like to generate a report for this. So put that information to the template, generate the report. You know what? App Formats is not only a report generator. App Formats is a very powerful log collector. So how powerful? You can use the app formats to collect the information from Amazon. Okay, so which means if you have a private cloud And some of the function you provided to your customer by using private cloud. But some of the function you cannot support. And the customer want to use some of the function like the Amazon. But you don't want your customer go direct to the Amazon, because if your customer pay to the Amazon, you lose your business, right? So you provide a page for the customer to click. Okay, I want to use this, like Dropbox. That kind of function provided by my local database, local data center. We call it private cloud. But there's another link. Oh, you can spin up a virtual machine, but since I cannot support that information, but customers still use my web to click that. But this command was sending to Amazon in the back end. So I'm actually, as a service provider, I'm actually providing not only my private cloud, but also the public cloud. So we are talking about hybrid cloud, right? Customer only talk to me, but customer using both of the cloud service. Now, one day, the customer comes to Sean again. Hey, Sean, I would like to know, I just saved a lot of file from this folder to another folder. In the back end, this folder is in the private cloud. Another folder is in the public cloud. And the customer said, can you give me a report? So in the back end, you need to have an application that is app formats, allowing you to collect the information from your private cloud and also from the public cloud. That's why app format is so powerful.
So is it like Splunk?
I'm sorry?
Is it like Splunk?
I don't understand that.
Splunk. You know
Splunk.
Splunk?
Oh, Splunk.
Reporting
More than
tool.
Splunk. More than Splunk.
Right.
Yes. It's more powerful than Splunk.
But that means that you have to collect the logs all the time in order to generate that report. So you have to direct these logs to that app from the start. To be able to generate that report.
You can set up a rule. Just like you said, yes, if let them to collect the information, they can constantly collect the information, but the downside is that will also generate the value, right? So you say, okay, no, I don't want to do that. I would like to set up a rule. The rule is I would like to see something, only that is happening. Yes, that's how you do it.
So is the app comics part of the whole package or is that separate?
Depending on which package you are talking about. Remember that yesterday we talked about, we have a package called control networking. No, not including app formats. Control cloud,
That's got that.
not including app formats.
What was that?
Control, there is a package, we call it Control multi-cloud. Then this package is included.
So that's what happened?
Come again?
That's just bought that package or?
Yeah, there is a package including the control itself, the OpenStack, and app formats. And
Telstra has this.
on Telstra, I don't know. I have to read through your case study because I got.
We might use Splunk for stuff like this. Because they invested heavily in Splunk.
You know Gartner.
Too late.
You know, there is a report generated by Gartner.
Yeah.
Gartner will always give you 4 quarters, right? So which product is the, for example, market leader? Which product is more business oriented? And which product is more proprietary? So you know the report. If you go to the report, the Gartner report always put the app formats on the upper right corner, which means not only the market leader, but also more popular in the market. Let's take a look at the monitor infrastructure workspace. Now we are talking about the control itself. In this courseware, we are not talk more about app formats. We talk more about control. So you are in the control. In the control, there is an icon that is called monitor. And under the monitor, you can monitor most of the things in the infrastructure. It will give you the dashboard. It will give you the control node, virtual router, analytics node, config node, database, for example. And it also gives you a chance to look at the security. Okay, now I would like to proceed. Security. Yesterday you did a lab. You configure a policy to your virtual network, right? So you have to apply the policy to first the VN left and the VN right. So you will be able to pass through the traffic. The traffic is called inter VN traffic. So what was the policy name?
Name
The
A to B.
No. I'm not saying the name of the policy. I'm saying how you call that policy. You call it network policy, right?
Yeah.
Network policy. So why I'm asking is because remember that network policy is used to control the inter-VN traffic. But what if you have a virtual network, only one virtual network, but with multiple virtual machines over there? They are in the same subnet, 10.10.1, 10.1.1, 10.1.2, 10.1.3. Are you able to control the traffic between the virtual machines in the same subnet? Of course, but by default, if you didn't define any of the policy, they pass through because they're in the same subnet. However, if you would like to configure that, that's okay. However, it will call another name. We call it security group. Security group. So comparing with security group and network policy. Network policy for inter traffic, security group for intra virtual network traffic, right? And both of this information can be monitored in the security. Okay, and in here, because yesterday you have done the lab, so you probably noticed that it will give you a monitor to let you know how many virtual routers over there. Now, whenever you see the virtual router in here, which means you have how many compute nodes. Remember, one compute node has only one virtual router. So you have two virtual routers, which means in your environment, you have two compute nodes. And then,
But the compute node can contain more than one virtual router.
no, cannot. Compute node always only has
Virtual
one
machine.
virtual router.
Virtual machine.
Yes. You can have multiple virtual machines, but only
Yeah.
one virtual router. And then, how many control nodes in your environment? How many analytics nodes? How many config nodes? How many database nodes? Now, all these nodes in our lab are installed in a single server, and that is control controller.
Yeah.
However, in our lab, because we want to reduce to minimize the resource consumption as much as possible, so we also install the OpenStack in the same server. And the host name in your lab, we just call it OpenStack. Right? So that's the lab. So if you want to build up the lab for your practicing or for the pilot run, maybe you can install like this, just like our lab. And here, it gives you an information about the control node. If you click the control node in the previous slide, and then it will give you some of the information like the packet, the control node, how many control node over there, and how many traffic passing through, and what is the CPU utilization, what is the memory utilization. If you look down to here, it will tell you that the control node is actually installed in a host. The host has the host name of OpenStack. What's the IP address, what's the version, okay? And you can look to here, CPU, memory, and how many BGP peers has been generated. And again, how many virtual routers represent how many compute nodes. If you click that link, let me stepping back. If you click this, oh, I would like to look at OpenStack. then it will give you the information of the detail of the OpenStack server. And it will give you all the information in here. Okay. You can also see from the from that server, we have the Contrail controller. And we have a node in here, config node. We have a node, we call it control node. And there is a node called analytics node. Since you have the control node will use the southbound protocol to talk to the compute node by using the XMPP, remember, right? And inside of the XMPP, they will generate the route. That is BGP route. So in order to push the route from the control node to the compute node, the control node need to first establish the BGP session to the compute node. All right, so everybody in here, I believe you are quite familiar with the BGP. A very simple question for you. BGP based on TCP or UDP?
TCP.
What's the port number?
400.
BGP port number.
Yeah, what's the
Autonomous
port
system
number?
only,
173.
3.
You want to try again?
174.
179. Okay, now this is the basic information. If you have two BGP router, they will start it with the three-way handshaking, right, to establish the BGP session. However, since you configure both of the device to enable the BGP, they will always initiate three-way handshaking this way and three-way handshaking that way. So at final, you will see two sessions over there. Two sessions will be built up, but only one session will keep. The other session will eventually be destroyed automatically. Because if you want to send the route, only one session it will be enough. So if you take the exam, some of the exam will give you a very, very difficult time about this. Can you tell me if you have two devices generating the BGP? So first, easy question, what's the port number? Okay, 179, I already told you. Second, since they will have to exchange the BGP, they will build up the TCP session. Two sessions will be established. Please tell me which session will eventually keep. So there's a criteria. The criteria is who owns the router ID. The higher the router ID will keep that session. Okay? And then that will be the second question. The third question is now you have two devices, let's say two routers. Now I'm the router, you are all the BGP router. I receive the route from you, that's the BGP route. If I receive a route from you, the route is going to a destination 10.1. I also receive the route from you, the route is all go to the destination 10.1. Now I have two BGP route entry. They are going to the same destination. However, the next hop is different. So in Juniper or in Cisco, in standard, two of the route will eventually to compete. One of the route will be become your best route. What's the criteria? What's the criteria? Can anybody tell me?
In BGP.
In BGP, yes. What's the criteria to select the best route? Okay.
So many BGP has so many attributes. The med, the low.
Yeah. A BGP route has so many fields. Each of the fields is an attribute. So if you have two routes, they will compete the attribute one by one. Okay. If the first attribute they are the same or equal, they go to the next one. If still equal, go to the next one. Eventually, one of the route will become a best route. So let me give you the idea. This is difficult. First, in two BGP routes, first they will compare with an attribute. They call it local preference. Have you heard about it? Local preference.
Yeah, yeah, yeah.
Local preference, the higher the better. But if local preference the same, the second one will compare with the AS path.
Yeah.
The smaller the AS path, or the fewer the AS path, will be the better one. If they still the same, they will comparing the next one. That will be the origin code. The smaller the origin code will be better one. If the code still the same, comparing with the MED. If MED is the same, then the next one will be, if I receive the route from you, we are eBGP neighbor. I receive the route from you, we are IBGP neighbor. I prefer the eBGP neighbor. So eBGP routes wins. Okay? If both of the routes are IBGP, then I will compare both of the IBGP route, how to reach out to their next hub by using the IGP. Which IGP has the lower cost? If both of the routes are eBGP, then I will comparing which eBGP route is more stable, which means if I receive the eBGP route from you for 1 minute, I receive the eBGP route from you for only 30 seconds, I will prefer 1 minute. If still the same, we compare with the route ID, and if the route ID is still the same, we comparing with the neighbor IP address. You can't remember, right? I know you can't remember.
I just remember determining a cost by multiple variables, so it's got like a process of elimination.
Yeah. But can you repeat what I said? Just say first one.
Local preference,
Second one.
AS path,
Third,
Yeah.
origin, something like that.
origin code.
Origin code,
Then
metric, weight, cost,
No.
routing, neighbor.
Hash,
man, yes.
L, onion. Like, I
And then now, give me 1 minute, okay? And make sure you will remember this at least 1 month, right? First, compare with. Don't laugh. What is the letter?
L.
L. Local preference. The higher, the better.
Yeah.
Local preference. Please don't laugh. Second, if local preference is the same high, how you call this? How you call this?
Bum.
S. AS path.
Oh, AS. Okay.
S. Alright?
Yeah.
AS path. 2 paths is okay. Too many pieces over there. It's not okay. Alright? Alright? And then moving up to here. Imagine that there is a code, a smaller code over there. Okay. Sometimes if you have a bigger code, no fashion. Smaller code is more fashion.
Smaller
Origin
code.
code. Origin code. Okay. If the code still the same, moving up to here. Stop. Yesterday you say something to me. So meet. I'm mad. So look at my shoulder. If I'm mad, the MED higher. If you treat me nicely, I'm not mad.
Yeah.
So MED, mad or not mad, which one is good?
Med.
Lower.
Lower
is
med.
good. Yes. MED. Okay. And then moving up to here. How you call this?
Years.
Here. eBGP. How you call this? IBGP. Okay. eBGP facing out. So eBGP over IBGP. Am I right? eBGP better. Okay. Now I'm stopping here. I have 2 IBGP. So when I look at newspaper, the closer is better. Right? So 2 IBGP, the closer one will be the better one. Now, I have nothing to compare. Do you know what is this?
Card.
Access card badge. Okay? But if you guys have your badge, right? So if you look at your badge, there's always a number. What is the number? Employee number. Now, please tell me, normally the number is the smaller represent more senior, or the higher number represent more senior? Smaller. So this is my router ID. You send me the route, you have the router ID. You send me route, you have your router ID. So I will look at your page. Which one has the smaller number? Route ID, the smaller, the better. Okay? And then until the end, if both of you are using the same router ID, because actually you are the same router, but connecting with me by using different links. So I receive two routes from the same router ID that's the same. Then I compare it with IP. Good. Check. First one. Local preference. That will be your turn. First one. Local preference. Higher or lower? Lower. Second.
ASPAD. ASPAD 2.
The fewer the better.
The fewer the better.
Yeah, the fewer the better. Too many pieces over there, no better, no good, right?
Yeah.
Okay.
2. Yeah.
Now,
The fewer the better.
origin code, bigger, smaller, smaller the better. Now, please. Matt, higher the better, lower the better.
Lower.
Lower the better. Please.
The EBGP.
EBGP better than IBGP. Good. EBGP better. Now again, I have two routes from the IBGP. Which one is better?
The lower number.
The lower the number, yes,
More
yes.
senior.
Which means the closer. Okay.
Means
The
better.
IGP cost closer the better. Then the next one.
The next after your I, it's the employee ID. The lower
What you call this?
router ID.
Yes. Route ID. The
Router ID is the lowest the better.
lowest the better. And finally,
IP.
IP, right? IP, the smaller the better. You know, I invented the way to remember the BGP comparison, okay? But there is an even better way. Can you remember the order in reverse?
No.
Starting from IP,
IP, yes.
and IBGP. Oh, sorry, router ID,
Route ID,
and then
then
IBGP, lower IBGP, and then
BGP, which one is better?
outer,
Longer,
better, and
then
then
EBGP
med,
over IBGP, right?
EBGP over
And
IP.
then,
Med is lower.
and then,
Origin is
origin code.
origin code.
And then,
Origin as ASPAD is lower. Local preference is
you
lower.
see, you won't forget. Okay?
I remember there was a word to the letters.
That's a very good
You
one.
write that, I remember some word that you write down and you can remember it.
Oh, you mean the 7 layer?
Yeah, no, for this the BGP.
For the OSI 7 layer, right? OSI 7 layer starting with the physical layer. Physical data link
this
network. I'm
procedure
talking about that.
here is with the way the BGPs.
The BGP.
Yeah.
There are so many ways
so
of
long
to
ago.
remember. Just give you the idea.
No, this is very good actually. I will always remember the story, whether we remember the ASPAD.
You remember that part?
Yeah, I mean we remember both. But
Just that? Okay.
it's very nice actually. Very
Okay.
creative.
Now let's move on. Okay, just very interesting, right? Because every day, just like you, you have so many work to do. You have so many things to remember. I have so many books to read. So my ex-boss, one day he came to me. He said, "Hey Ivan, why can you remember this?" I said, "Oh, because too many things to remember." My boss said, "Don't give me excuse. Do whatever you want. Do whatever you want to remember it. Okay? Think about the rule. Think about the rule to remember it by yourself." So I just learned it from my ex-boss.
Is your Xbox is here in Melbourne? Oh,
My ex-boss is from Hong Kong.
The term you were saying, we love oranges as oranges mean pure refreshment. The first characters.
Yeah.
Read that symbol.
Yeah, you know, I remember. I just it's gone out of my head. But for all of this stuff about remembering stuff, someone always has a
Yeah,
word,
read it in a
and you just remember the word, and then you just write the word down, and then you go and then because you got the first letter.
first
And
letters.
Yeah, how you remember the 7 layers?
I forget that as well. No, I mean,
All people
I
seems to
remember
need
it.
data
I
processing.
remember it when I
Come
need
again,
to
come again.
study.
All people seems to need data processing.
All people seems to need data processor. You are remembered from bottom to
Yeah.
top. So how about from top to the bottom?
Whoa.
Just do the reverse. No,
Yes.
Write it and do the reverse.
don't need to write it.
You can tell us.
All people should try new diet Pepsi.
Pepsi?
That's a word, Pepsi.
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 The drink.
All people should try new diet Pepsi.
All people should try new diet Pepsi.
All people should try new
Diet.
diet Pepsi. All people should try.
Just for fun.
All people should try
It's the same
new.
way- It's the same way top to bottom. All people seem to need data processing. Application, presentation, session, transport network, tunneling, and physical.
All people should try new Pepsi.
New
Oh, new
diet
diet.
Pepsi.
Good
Diet,
diets
yes.
are not.
Oh,
Normal that's not good for you.
we should try.
Okay, now here, let's stepping back. In here, from the controller node, you need to know who is, I'm established the BGP neighbor to where, okay? So you will have 2 nodes in the previous slide, 2 compute node, which means 2 vRouter, right? So you see, you have 2 vRouter running with the BGP session, but that is XMPP. And the BGP session has been established. And you will see how many messages. This is talking about the BGP messages. How many messages have you received and sent? Okay. And you can also look deep to the routes. Now, if you look at the routes in here are the routes. And oh, wow. The routes like this. What is this part? This is a route, but what is this part?
That's the network prefix.
No, because this is a VPN route. So VPN v4 route.
Source
So
address.
this is IPv4. What is this part?
Source.
RD.
Routing.
Routing what?
Routing.
Destination.
Route distinguish. Distinguish.
Ah.
Okay, RD. Okay, that is part of the MPLS VPN. Okay. And then you can take a look at the log from the console. Here is the console. Before you parse any of the log from the analytics node, you can provide some of the criteria in here. For example, I would like to use the keyword. Any of the log have this keyword I would like to see. And here's the time range and what types of the log you can also specify in here, right? And here is about the node status. You can see that we have a virtual router nodes. Now, if you see virtual router node, virtual router in here, you will see there is a bubble. A bubble. The bubble, the number of the bubble, if I have many bubble over there, which means how many V routers over there, which also means how many compute nodes you have. Okay, and then you will see, since I have probably 2 bubbles in the slide, one of bubble probably hidden in the back in here. So 1 bubble, 2 bubble, so which means you have 2 compute nodes. If you click each of the compute node, one of the compute node, it will showing you the detail of the compute node. One is the IP address and the rest of the information, including the CPU, including the memory. You can examine the V router interface. All right, now I would like to pose it here. When we talk about the V router, okay, there is a circle connecting to the hypervisor and eventually go to the virtual machine. Yesterday we mentioned about virtual machine has the interface, we call it ETH. And there is a logical interface in the V router, how we call it tab. Right. So they would one-to-one mapping together, one-to-one mapping together. So if you go to the V router and click interface, then you will see the tab interface. Now, since you have 1, 2, 3 tabs interface over there, which means you are connecting to different virtual machine. And this tab interface, you can imagine that you have a device, which is FTP server, you have a hypervisor, and there is a V router. And V router from here, you can see that there are 1, 2, 3 tabs. The tabs, each of the tabs connecting to a virtual machine. But I will connect a tunnel. And inside of the tunnel, we have the virtual network. So how many virtual network we have? If you look at here, I have virtual network A and virtual network B, right? Probably two of them sending to the same virtual network. Another virtual machine sending to the second virtual network. How do I know? These two virtual networks connecting to VMA3 and VMA1 because they are belonging to the same tenants. These virtual networks connecting to VMB2. Can you see that? This is another tenants. So that's how you identify the location. You can examine the vRouter networks. For example, networking here, and you will see, okay, there, I have the VNB, I have the VNA. And the VNB, VNA belonging to which tenants or demo? Now they are belonging to the same customer. All right? Now, let me repeat that again. I just say that if you would like to control the inter-VLAN traffic, what should we do? What should be done? What kind of the policy should be configured? Network policy. If you would like to control the intra-VLAN traffic, what should be configured? Yes, security group. Either the network policy and the security group, they are all ACLs. They are actually all ACL. So if you configure security policy, you configure network policy and security group. They are all showing you under a page. We call it ACL. So you go to compute one of the compute node. You would like to see how many filter has been configured. You click the ACL, and then you will see, oh, there are so many ACL over there. And for example, one of the ACL is trying to passing through the traffic from the VNA to VNB. So since this is used to control the inter-traffic, so we know that is configured by network policy. However, if you see something like this, you would like to pass through the traffic from any protocol, from any source to any protocol to some other destination, not showing here. But it didn't show you the virtual network, which means actually the source and the destination are in the same virtual network. So this is configured by the security group. Okay, it's not showing you directly, but you need to understand this is from the network policy. This is from the security group. This is inter-traffic. This is intra-traffic. And you can see the vRouter traffic flow by clicking the flow. So again, flow is single direction, right? So if you see the flow, it will give you that, oh, based on your policy, you are currently passing through the traffic, which is ICMP, from the VNA with the virtual machine source IP address 4 to VNB with another virtual machine with the IP address 10.2.0.4. and how many traffic has been passed through. And for the virtual router, let me draw that again. If you have a virtual router, however, you have two tenants. You have a tunnel, but you have two virtual network. They will create two VRF. Because different tenant, the route should be separated from each other. So different tables will be generated. So if you would like to know, this is the virtual router. And for which VRF routing table you want to see, you can select from here. Okay, which VRF? So you can select the VRF. And if you click the VRF, it will give you all the routes in here. So whether the routes has been learned or whether the route has been saved. So it will give you that information. VRouter instance. Okay. Again, it will give you how many instances has been spin up in the compute node. Again, one instance, not necessarily one virtual machine. One instance probably will has more virtual machine over there. So if you click instance, which means it will showing you how many instance over there. So if you can see instance name is VMA3, VMA1, VMB1. And they are currently connecting to which virtual network and how many interface. I'm talking about the logical interface of the virtual machine and what is the IP address and what's the traffic. Here is talking about the analytics node itself. Analytics node should maintain a large database because everybody will report information to the analytics node. So you might want to know how many resource has been used in the analytics nodes. And here are some of the detail. Just to give you the idea, the analytics node is in a host with the host name of OpenStack and what is the IP address. So you know where is the analytics nodes. And it will give you the generator. So generator, which means the analytics node collect the information from the other nodes. So the other node is generating the log. So what are the other nodes? So who is generating the logs to analytics node? So you will see that, oh, as an analytics node, I have collected that information from, let me give you some of the example, from config node, okay, from SNMP, okay, you see SNMP, from controller node, right? So you will see the analytics node currently receiving the information from where? Normally, if you see there is one node, always keep a number of 0, which means your analytics node losing the connection to that node. So that is something you need to troubleshoot deep. Config node. Config node is, again, in the control controller, the config node providing the northbound API. Again, what is the northbound API? REST, right? REST. So if you go to the config node, you can see the detail. And where is the config node? What is the IP address? And they are providing the API server, that is REST API. And again, database. Okay, you can see the database information. And you will see how many storage has been used, how many storage are available. Okay, let me pause in here. This is only to give you the idea how you can, what kind of information you can monitor from the control node, okay, by using analytics. So, okay, I would like to take a break. I think you need to take a break. But before we taking a break, I will make sure the information I just gave you has the warranty. So when we compare two BGP routes, which attribute will be compared first? Shane?
Routes.
No, the local. Lower is better, local.
Higher, lower,
Lower is better.
lower better, higher better,
High is better, yeah, that's right.
higher better. Second,
Smart. Lower, fewer the better.
fewer the better. Third,
Origin code.
origin code, lower the better. Lower better. MEP, please.
External BGP over internal BGP.
eBGP over IBGP, TGP.
So eBGP is better. That means. Yeah. Okay.
Yeah, because it
If I have- Yes. If I have two IBGP, which one is better?
Lower. Closer.
the closer one,
Closer one.
comes out more steam.
Right. If I have two IBGP, which one is better?
Two IBGP. You have two IBGP. eBGP.
Oh, I'm sorry. Two eBGP, I'm sorry. My
Yeah.
bad. Two eBGPs,
Yeah.
which one is better?
Higher the better. Lower.
No, these are router IDs, right?
Which one is more stable?
The router ID.
Closer.
Come again?
Closer one.
How you define closer?
Lower.
I just give you an example. I received eBGP from you
Yeah.
for 1 minute.
Yeah.
I received eBGP from you for 30
Right,
seconds.
so, and those are defined by router ID numbers, right?
Not yet, not yet.
Oh, that's
Not yet. Now we are talking about eBGP.
Yeah.
So
Oh,
I learned the eBGP, but the longer the better. Okay?
So E is better because it's.
Try that again. Local preference, ASCAP, origin code, MED, and then eBGP better than IBGP.
Yep.
If you have two IBGPs, closer is better.
Yeah.
If you have two eBGPs, longer is better.
Yeah.
Okay. Now the next one will be Router ID.
That's right.
how you compare.
Lower, lower.
And finally,
IP.
IP. Which one is better?
IP address is lower the better.
Lower. Right. I think that should be very useful for you since you are working on the BGP, right? Okay, thank you. Thank you.
Thank you.
Okay, let's move on. Right, starting from here, I just go through it quickly because every slide just give you the idea how to collect the information, how to look at the statistic. So that's not very important unless, as long as you can do the lab, right? So I'll try to give you more time to do the lab. So here we are talking about the flow, query, logs, and the statistic. So which means it's providing you a way to provide the criteria to analytics node, and based on that, you can query the information as you need. So there is a query under the query flow and the query session hierarchy of the contract. So now, if you would like to do the query, click this, which is the icon of the query. We have the flow series under the flow. And we can also have the logs over there or session over there. You can query from there. Again, you provide your criteria, for example, the time, the type of the log, and where, which means who generating the log. You can provide that information. And then you will go to the flow series to provide a time range. So you can say, okay, I would like to collect the information from since the last 60 seconds. And then it will generate the log every 60 seconds. It also showing you
Sorry,
this.
just quick 1 minute and pick up some things.
Oh, okay.
Thanks. Sorry.
Right, and it will also show you a chat view. So you will see, okay, during that 60 seconds, what is happening? It will give you the statistics. And then another one, flow record, again, providing the criteria. Then you can collect the information. And again, it will show you those information generated by which computer node or which node. And there is a function, if you click the icon in here, that will allow you to export the information as raw data, or we call it CSV. CSV stands for comma separated value, right? And then you can export this information to either F4Max or any other report generator. You can query the session. Again, provide the information. For example, which V router, which VM, or which virtual network generating that traffic to where. And then it will give you the information. Also, each of the session will give you the record, and the record will give you a way to run the detail. For example, you can see the detail based on the IP address and protocol and phone number. And you can configure the session export rate. Sometimes you don't want to generate the session one by one because it will also generate the traffic. So there is a way. For example, you tell the Contrails, hey Contrail, I need to know the past 1 hour statistic of the traffic, but don't give me the packet information one by one because I know that will generating the traffic in the network. So please summarize the information in a period of the time. And then based on the period of the time of the trend of the traffic to calculate what will be total amount of the traffic. Okay, so you calculate only part of the information, but you give me the full statistic by accumulate the information, by anticipate the information. So that is how it works. We call it export rates. And you can also understanding that flow sampling. You can sampling the flow, which means you can mirroring the traffic and sending to a virtual machine. Now here, if you would like to query the log, you can have a system log. The system log, which means the log generated by the node itself. If there is something wrong, the log will tell you, and you would like to troubleshooting. Okay, let me skip some of this. And then, now, here's something probably more interesting than the rest of the chapter. Configure Contrail analytics. If you would like to collect the information, but you say, all right, let me give you a criteria. Since I have limited storage, if you collect all the information, it will be thousands of gigabytes over there. I'm not able to collect every information. So I just give you a TTL. The TTL is time to live. You can save that information for how long, okay? If the time is exceeding, purge the database automatically. So that is the TTL you can configure. If you would like to configure that, you are not able to configure in the web UI, you will have to go to the command line. Under the etc Contrail controller, there is a file with the extension name of conf. You put the command in here. Analytics config audit TTL, analytics status data TTL, analytics flow data TTL, and analytics data TTL. This information is to tell your device in the lower level to tell that how much information and how long the data should keep in your database. And if any of the data exceed that time, it will be purged automatically. But somebody will say, oh, no, I don't want to purge anything. If you want to save the data storage, any of the data exceeding that time, can you just cut it to another storage, for example, another database automatically? Yes, you can do it, okay? But you need to configure the file in here. Just remember the file. Under the etc control, the file name is control-collector.config. Right, and here is going to give you some of the information. If, just like I said, if you would like to export the information to another storage like the syslog server, then how you configure that? You can enable the control collector to receive the information from the syslog server, or you can export the information to the syslog server. And your vRouter agent can also be configured to send the flow information to the syslog server. So here are some of the ways that you can configure. Cell meter. Cell meter, that is to remote parse the information from the virtual machine. I'm talking about the remote, which means I'm in the Singapore data center, but I would like to parse the information from Oregon, all right? So how you parse that information? There is a function we call it cell meter. Again, cell meter will be handled by a project, okay? Can anybody tell me what was the project name for the cell meter?
Telemetry.
Telemetry, yes.
Telepathy telemetry.
Yes. And the last part up in here, that will be the analytics API. Again, it will give you the URL and the port number where you can send your command to the API interface. And by going through that API interface, you can collect all the information. We call it UVE. Again, UVE stands for User Visible Entity. And in the User Visible Entity, some of the example, that is, it will give you the very detailed information about the virtual network, virtual machine, vRouter, and the service chain. So you just put the URL, which means you are talking to the API, and then it will give you a web page, a very raw data of the web page. And you just click one of the link, then you can collect the UVE information and showing it on the web page. And here are some of the links. For example, you can go to one of the links, allowing you to go to the OpenStack analytics node to collect the UVE information about the vRouter, about the compute node. And it will showing you the format like this. Other log and flow information can also be queried by using the API, and here are some of the API examples. Okay. Or you can use the JSON to scripting, put your script and send the script to the API. So again, you can use the soft coding to code your query to put your criteria to the API. All right? So that's how you collect the information. There are several different ways that helps you to collect information from the control nodes. Okay. So we just finished up the chapter 12. But before I let you doing the lab, I would like to move on one more lab, right? One more chapter. This chapter is chapter 13, analyzing network state and the traffic flows. Again, it's very similar to the previous slide, previous chapter. However, in this chapter, you are going to do a very interesting thing. That is, you are going to spin up a virtual machine. The virtual machine is a pre-built virtual machine in Contra. It's a Linux. Inside of the Linux, it's already pre-installed with an application. We call it, everybody knows it, that is Wireshark. So you can install the virtual machine with the Wireshark. That virtual machine is connecting to a virtual network, for example, virtual network C. But you can configure a policy. For example, you have a virtual machine in here, VMA, another virtual machine over there in the virtual network B. Now, you spin up this Wireshark in the virtual network C. You are in different virtual network. By default, you won't be able to see the traffic, right? But since you are running with the Wireshark in the virtual network C, you can define the rule. For all the traffic between virtual network A and B, please mirror to the virtual network C. So the Wireshark can capture the traffic and you can analyze the traffic in detail. So that is what you're going to do in this chapter. Right. Let me skip some of the slides in here because those slides are very similar to the previous chapter. Let me skip this. All right, please go to page 19.
So why do we need to install capture with Wireshark?
Yeah, because Wireshark allowing you to capture the packet and analyze the traffic, each of the packet in 7 layers. Right, and that helps you troubleshooting. Okay. Now I have a question for you, only for interest. Sure. You told me your story about your history, how you started with your business, how you learned the technologies. Is there anyone very similar to like your master during your learning? He gave you some of the suggestions and tell you how to learn. Is there anyone over there? Yeah. Yes. Okay. I do. I have my master. Okay. When I was very young. But let me give you an example. My master is a very traditional engineer, and he was very tough. So you know, in Chinese, in China, when there is a princess, okay, I'm the princess. So if I learn something, I will go to my master. You're my master. Hey, master, can you tell me that? Can you tell me this? If I ask the same question twice, you know, what would my master do? My master will go to behind me and flash my head. I told you, don't ask again. Very tough, very tough. But I still like to learn from him because he knows a lot. Let me give you the information. The information is a very basic 7 layer. If you have a device, this device is a PC. Now you are in here. You try to use the FTP, sending the FTP. The FTP is a file, 1 gigabyte. 1 gigabyte is a big file. So everybody knows you won't be able to send a single file with a single packet through your network card, right? So in that case, your PC, FTP is an application. It stands in the layer 7, 6, and 5. And in this layer, we call it higher layer application. That FTP will segment the traffic into a smaller portion. We call it segment. So the smaller portion of the information will be sending to layer 4. Now in layer 4, I know FTP is based on the TCP. So in layer 4, that information will be encapsulated with a TCP header. However, since this traffic eventually will be sending to the other side, in order to let the other side identify which upper application should be used, so in here, in TCP, we have the port. We have the source port. We have the destination port. Since my source upper layer is FTP, so normally the source port is 21, right? Now, if I move on to the layer 3 will be encapsulated with the IP. So again, the IP will be encapsulated with the header. However, the IP will have to identify what's the higher layer. Higher layer is TCP, but sometimes it's probably not TCP, probably UDP, probably ICMP. So in order to identify the payload or the higher layer, there is a field in the IP header, we call it protocol. And if you're sending the traffic to layer 2 will also do that, but we encapsulate with not only the header, but the trail. The trail is the frame check sequence. It's a checksum. And in the Ethernet header, there is a field to identify what is the upper layer or the payload. We call it type. Okay, now let me wait in here. If I ask you the port number, how many port number you can remember? You probably say a lot. Port 21 is FTP. Port 23 is Telnet. Port 53 is DNS, something like that. Okay, that's not a big deal. If I ask you for the TCP, oh, everybody knows the port. How about the IP port code number? How many port code number you can remember? Let me give you some of the idea. If the upper layer is TCP in here, in order to identify the payload, IP port code number will be 6. If the payload is UDP, that would be 17. If the payload is ICMP, that would be 1. If the payload is IGMP, that would be 2, etc. Okay? You probably say no big deal. I can still remember that. Now, my master, he asked me to remember if this is Ethernet, what's the payload? But since the Ethernet has been defined by IEEE, so the number in here normally will be hexadecimal. So in here, that would be hexadecimal of 0800 to specify the payload is IP. 8100, that would be the payload, that is the VLAN tag. Now, I say 4 number in hexadecimal, 0800. Each hexadecimal represents 4 bits. So how many bits over there? 16 bits. So 16 bits will be used to identify the payload. Different protocol in here. 16 bits can be used to identify how many protocols? 2 powered by 16, right? 2 powered by 16, which means 64K. But not all of them has been standardized with a number. Only half of them, which means 32K. But you normally will use the popular protocol, probably half of them, which means 16K. Even 16K is a large number, right? My master can remember half of it.
Oh my God.
Without using a Wireshark. He just tell you 9011 is MPLS, 9022 is what? 9023, 9024, 9025. He just remember everything. So when I asked him the same question twice, he said, I already told you, don't ask. Okay, it's just flattening my head. Okay, so that was tough. So that was a traditional engineer. Traditional engineers do things like that, try to remember everything. But nowadays, we don't do that. Because if you have any question about it, we'll say, hey, Google it. We'll say, Google it. But sometimes if you are managing a cloud, you probably not be able to Google it. So that is why we need you to know how to spin up the virtual machine with a Wireshark to capture the packet, to identify whether the traffic is from the virtual network A to virtual network B, what kind of protocol is running, okay? So it helps you to identify the packets. Now, we want to traffic analyzer. There are 2 different ways to spin up the virtual machine. One is go to the control monitor, debug, packet capture. Another one is configure service. Either one are okay. Now, let's go to one of them. First of all, you need to upload the analyzer image. So where do you get the image? Go to Juniper website, download the image from the Juniper website, and then upload to OpenStack. So we know how to upload the OpenStack. We go to the image and create the image, which means upload. And then we create image. We say, okay, this is a virtual machine, has the Wireshark pre-installed. This image has to be called analyzer, so please be careful. This name has to be analyzer. Okay, exactly the same. And then you need to browse the file from your laptop and specify the format and then upload the image. After you upload the image, then you can spin up the image. Before you spin up, you can first make sure, okay, the image with the analyzer name is already there. Now, here's the case. I want you to spin up that image, become a virtual machine, pre-installed with the Wireshark. And since you have an existing network like this, you have green network with 3 virtual machines, A1, A2, A3. You have red network with virtual machine B1, B2, B3. And your purpose is you want to use the monitor debug packet capture workspace to spin up the virtual machine and to mirror the traffic communication between VNA and the VNB. So any traffic between them, please mirror that traffic sending to your virtual machine and captured by the Wireshark, so you can analyze the detail. That's the job you want to do. So we go to monitor, debug, packet capture. Under the correct tenants or project, we click create. And then we say, okay, I want to create an analyzer. The analyzer, we call it VNA to VNB. And I would like to capture the traffic between virtual network A to virtual network B. So I associate to these 2 virtual networks. And if you would like to give it more detail, for example, I'm not going to see all the traffic between VNA and VNB. I would like to narrow down the traffic by specifying the port number. Okay, you can specify the port number. You can even add more rules in here, so you can narrow down the traffic. And then after you finish the configuration, now here's the key. Go to the gear button. There is a drop-down menu. Select the View Analyzer, and then voila, the virtual machine is up and running. And if you open the virtual machine, actually it's a Linux pre-installed with the Wireshark, and the Wireshark is also up and running. Okay, so for you it's easy. Just spin up the virtual machine, capture the traffic between the virtual network. Now you can see that it's a Wireshark. Everybody is very familiar with the Wireshark, right? So if you click this, one of the packets in here, it not only give you the summary, but also give you the detailed information. All right. Since I'm also an old-fashioned engineer, so when we talk about the 7 layer, layer 2, layer 3, layer 4, right? So if you click expand that information, it will give you the detailed information. But now, since in this case, if you click this is Ethernet to header. Then when you click this, it will mark part of the information over there. And 2 numbers over there represent 1 bytes. If you click the Ethernet header, can you tell me how many bytes will be marked? Can you tell me how many bytes?
How many?
If you click the Ethernet 2,
yeah,
which means you want to focus on the Ethernet header.
Yeah.
How many bytes in the Ethernet header?
Hexadecimal. So
Yeah, in hexadecimal,
16, 12 bytes.
you have in the Ethernet header you have destination. No. I just put that for example. I'm asking you the actual bytes. How many bytes? If we are talking about Ethernet header, including destination MAC address, 6 bytes. Source MAC address,
6 bytes.
6 bytes. And type, 2 bytes. So 14 bytes. But there is a trailer, FCS, remember?
Yeah.
FCS comes with 4 bytes. So in between, that is the payload. Payload including the IP, TCP, and the upper layer. By default, we call it IP MPU by default 1500. So if you accumulate all this 1500 with the header, how much?
14.
14.
With the trailer, how much?
4,
So
18.
what's the total?
1518.
1518. Okay, so that is the physical MPU size. So when we talk about the MPU, be very careful. People say, hey, what's the MPU? You have to ask which part of MPU, right? You're talking about physical MPU, including Ethernet header and trailer. If you are talking about IP MPU, only the IP header and the payload. If you are talking about MPLS MPU, you are not only talking about the Ethernet header, you also need to calculate the MPLS header, and then its payload, and then the checksum. So when we talk about the MPLS header, each of the MPLS label come with 4 bytes. But if you are talking about MPLS VPN, at least 2 header, so 8 bytes. If you are talking about MPLS VPN with traffic engineering, then you probably need to have 3 header of the MPLS, which means another 12 bytes in the MPLS because 3 header, 3 MPLS label. So if you plus 1518 and plus 3 MPLS header, what will be the total number? 1518 plus 4 plus 4 plus 4.
12, 1518 plus 12.
1530.
Okay, so that number will be the maximum MPLS MPU.
1500 is the total packet size, yeah?
This is jumbo
1500 is the total packet, only including the IP and its higher layer payload.
So when you minus
Isn't the packet only
all the headers,
432?
they should be 1476.
Okay, let me draw that in this case. I just mentioned about if you send the FTP, 1 gigabytes, okay, FTP. But it will be segment in the layer 6, 7, 5. So we call it segment. And the segment in layer 4 will be TCP. TCP by default 20 bytes. And in the layer 3, that will be 20 bytes by default, IP. Now in layer 2, if we are talking about MPLS, then you will have 1, 2, the maximum is 3 MPLS header. So MPLS, MPLS, MPLS. And then that will be 4 bytes, 4 bytes, 4 bytes. And then in the Ethernet, it will be encapsulated with Ethernet header, with the destination, with the source, with the type. And this is 6 bytes, 6 bytes, and 2 bytes. And with the checksum, that is FCS, that is 4 bytes, right? So when we talk about the IPMTU, IPMTU started from here, ending in here. And by default, IPMTU is 1500 bytes. But if we are talking about MPLS
So
MTU,
IPMTU doesn't have the source and destination. How come?
IPMTU including the source IP and the destination IP, but without the Ethernet source and the destination.
That's an
Can you
Ethernet
say
packet.
that?
Sorry, come
Can you
again.
say, can you say that again?
Okay, when we talk about the IPMTU,
Yes.
Easier way to say is, I'm talking about the IP header and its payload. What's the maximum size?
Yes.
So we call it 1500, including IP and payload.
What's
So
the
we
IP
have
header contains of?
IP contains the IP source, IP destination.
Exactly. So why? All
That
right.
is Ethernet.
Okay. So if you minus the source and destination, that would be 14. This is 26. 1474.
20 by default 20.
20.
Yes.
So it will be 1480.
If you minus IP header, the payload in here
Yeah.
will be 1480.
Okay.
If you minus the TCP again, that will be 1460.
1460.
Yes.
Okay.
And normally the 1460, we call it maximum segment size.
Is this the standard Ethernet
It's
packet?
the standard.
Okay.
Correct.
So something, no, I think not for me. Alright, so you add the MPLS, which is the inner label, outer label, and
Yes. Inner label, outer label, and the traffic engineering label.
yeah,
Yeah. If maximum you have 3.
okay.
Okay. And in that case, you have to add on 4, 4, 4. So that would be 12.
Well,
Right.
yes,
12 plus 1500. That will be started from here
yes,
to here is the MPLS header with your payload.
yes.
So MPLS MPU. But if you are talking about physical MPU, normally when people saying about physical MPU, it's talking about the Ethernet header. If you include the Ethernet header, then you have to add on with 6 by 6 by 2 bytes. Starting from here, ending, now here's the problem. Ending in here or in here. Any idea? You calculate the size from here to here or to here.
To the end.
To the end? Now, some of the vendor consider that frame check sequence is not part of the data. It's only checksum.
Yes.
So some of the vendor I'm talking about, including Juniper and Cisco, we calculate stuff in here.
15 basic steps.
But if you talk about some of the vendor from China, they calculate to here. So if you use the command line in Juniper, now this not considering the MPLS, that will be 6 plus 6 plus 2, that will be 14, right? 14 plus this part, that will be 15, 14, right? So in Juniper, if you show interface extension, it will show you physical MPU is 15, 14.
15, 14 or 15 volt plus 14?
Without considering this.
No, 15 volt because of the.
This is
Oh, this is
1500.
15.
Yeah, from here,
Sorry,
right?
sorry.
Now we plus this part.
Yeah.
So that will be 15, 14.
15, 14.
But we didn't configure this part.
Yeah.
If you go to some other vendors, you use the similar command to show the physical MPU size. It will give you 15, 18. Because they calculate this part.
Yeah.
But actually we are the same. You say 15, 18, I say 15, 14. Actually the size are the same.
Yeah.
It depending on whether you consider this part is part of the data.
Yeah.
That's it. Okay, so you can analyze the traffic from here. There is another case study. You can use the packet capture tool again, but this time you want to use the different ways to spin up the virtual machine. So you analyze the virtual machine, but you want to use as minimum resources as possible. So you only want to use the 512 megabytes of the RAM for that analyzed virtual machine, which means the virtual machine installed with the Wireshark. You can launch the analyzed virtual machine, but in this case, you need to use the version 2. We call it service template. There is a predefined template. We call it version 2 service template. It will allow you to select the flavor for this virtual machine. So the flavor you will use with 512 megabytes of the RAM for this virtual machine. Okay, so you go to service template, and then you click create the template. You select the service template version 2, also provide the name, and you say, okay, I'm going to spin up the virtual machine, which is a service. The service is transparent, which means I would like to transparently sniffer the traffic. So the service type is a pre-installed virtual machine. We call it analyzer. And then how many interfaces you need, you can create. By default, only one interface is needed. And then you can specify that interface will be connected to which virtual network. And then after you finish up all the configuration, the service or the virtual machine will coming up automatically. So it will give you the status active. And then you can create a policy. Say what kind of the traffic should be mirrored to this virtual machine. So this virtual machine Wireshark can get the traffic. So you can define the policy. You create a policy in here and you define, oh, for the traffic from virtual network A to virtual network B, I would like to sniffer to that virtual machine. However, I would like to sniffer both directions. So you can select bidirectional. And then, again, the service will come up, and then you will see the Wireshark. You can capture the traffic between these two virtual networks. And some of the information that in here, that is, you can also do the network card mirror. So as long as the virtual machine network card connecting to that interface, to that virtual network, all the traffic will be mirrored to the interface. And then you can monitoring to the analyzer IP. You can use the command line to verify whether the traffic passing through the virtual network. Okay. Let me pause in here. I'm not going to cover the last part. The last part is underlay, overlay, mapping. I'm going to give you that basic information in this afternoon. But let me stop in here. Just summarize. We are providing you a way to spin up the virtual machine. And the virtual machine is an image pre-installed with the Wireshark. It's connecting to a virtual network. But if you would like to see the virtual network A and B, if they are transmitting the traffic, there is something wrong, but you don't know. What you can do is define a policy for all this traffic between virtual network A and B, mirror that traffic to this virtual machine. So you can take a look at the detail by using the Wireshark. Okay? And some of the time, most of the time, you can use the Wireshark to see, oh, the VCQ MPU size is incorrect. Okay? So that is why the traffic not be able to passing through. Or the MAC address is incorrect. That is why the traffic has been blocked by the policy. Okay, so you can specify the detail. All right. Any questions out there? If there is no question, how about let's have a lunch break. Okay, and now is 5:12. I would like to ask you to come back before 1:20. Is that okay? Yeah. Good. Thank you.